Okay, so for this video we're going to do a quick introduction to trig identities, and then we will do two easier ones, and then I'll make a second video where I just go straight into the examples with a couple of the harder ones. Okay. So on here you can see 4 things that you should be looking to do every time you get a trig identity. And the very first one is a must, okay, before you start a question. If it is not already in terms of sine or cos, anything within the equation, then you must turn it into something in terms of sine or cos. Okay. Once you've done that, okay, it's usually necessary to do some algebra one way or the other. You're either going to multiply things together, factor, there should be maybe some canceling out. Okay. If you're ending up with fractions, where sine and cos top and bottom, and sometimes you can't put them together unless you have a common denominator. So if you have something divided by cos plus something divided by sine, you're going to have to get a common denominator. And then the fourth thing is to look for your Pythagoras identities, which is usually some form of sine squared plus cos squared equals 1. And so maybe, as a little note, the most common one would be sine squared theta plus cos squared theta equals 1. That's going to be the most common one. It doesn't look like my board's going to cooperate with it today, but hopefully we'll get through. So, that's the most common. We're going to do an example here. This is the first couple are easier ones, okay? And then again, I'll do a second video with some harder ones. Before we go into that, perhaps I can talk about just some of the identities and put them on this page. And there's of course sine and cos, which everything is going to be in terms of. And then we have cosecant theta, which is 1 over sine theta. Okay? And then secant theta is equal to 1 over cos theta. The board does not cooperate. Okay? And then we have cotan theta, which is equal to cos theta over sine theta. And finally, sine and cos, of course, and then we have tan theta, which is 1 over, sorry, not 1 over, it is sine theta over cos theta. So before I even begin, and of course, you probably don't have this memorized since you're just starting into it, I would have that on another sheet of paper just off to the side. So when you go to change everything in terms of sine and cos, you can go right away and look and say what each one is. Okay? So I'm going to be just doing them because I know them, and you should have that list written somewhere. So let's go back and do example 1. Here's example 1. You can see that I've got cos theta, can't do anything with that. There's cosecant, I can change that. There's tan, I can change that. And we should be able to make the left side equal the right side. Isn't really anything we can do with the right side, it's just 1. So we can't get any much simpler than just being 1. So we're going to simplify this left-hand side. Cos x is just cos x. Okay. Then we say cosecant is 1 over sine x, and tan is sine x over cos x. And this should all come out to equal 1. Now a couple of ways you can do this. You can start canceling things right away since this is all multiplication, or for some people that don't see it right away, they'll say I've got 2 fractions multiplied by one another, and this one isn't a fraction, but I can make it a fraction by putting it over 1. Then multiply everything on the top together. 1 times anything is just a cell, so I end up on the top with cos x times sine x. And then in my denominator, 1 times sine x is sine x times times cos x is equal to 1. And now I can start to cancel things. And I've got a sine x both top and bottom, and a cos x both top and bottom. Anytime you cancel, a lot of times people don't do it, what you're left with is 1. Here and here, here and here. So I've got 1 over 1, which is just 1, and the right side is 1. So now I have the left-hand side equals right-hand side. So therefore I proved my identity. Okay. So there you go. I just had to turn everything in terms of sine and cos, do some algebra, and then one side equals the other. So we'll do a second example. Okay, so here I have an equation where everything is already in terms of sine and cos. So I can skip right past that first step. So I'm going to be looking to either factor or expand. I can't expand, there's nothing to expand, but I can factor. Okay? I've got a sine in both this one and this one that I can factor out. Okay? So let's factor out sine in both of those. So if I factor a sine x out, that'll leave me with sine squared x plus this brought out leaves me with just cos squared x equals sine x. And the right side is already as simple as you can get. I can't simplify the right side. So now I look at this and say, what do I have now that I've factored? Well, I've got a sine squared plus a cos squared x, which if you go back to the very first sheet, this is the identity that I told you to look out for. It comes up quite a bit. There's sine squared plus cos squared. Sine squared theta plus cos squared theta is equal to 1. So anytime I see sine squared theta plus cos squared theta, I can replace it with 1. So let's go ahead and do that. And I end up with sine x times, we're going to replace this whole thing with 1 equals sine x. 1 times sine x is just sine x. So I have sine x is equal to sine x. Okay. So now my left-hand side is equal to my right-hand side. So that's my identity. And so those are a couple of the easier ones. Next, I'll show you a couple of harder ones. Next